Okay. So we're doing 2 problems today. The equations that you need for this problem are right here. So you start off with calculating the total energy that goes through this sheet in 4 seconds. So you're given this, which converts to 975, and you convert it to electron volts. Yeah, by multiplying it by 1.6 times 10 to the negative 19.
Wait, what are you doing?
Don't you have to convert it?
No. Later.
Oh, you convert it after. Okay, I guess you convert that after. So you first find how much energy goes through this sheet in watts per meter squared before you convert it to electron volts. So you multiply that by 4 seconds, and the area of the sheet, which is 0.25, multiplied by 0.15 meters, and you get 146.25 meters squared. Right? No, joules.
Yeah, joules.
And then you convert joules to electron volts by multiplying it by 1.6 times 10 to the negative 19. And you get 9.14 times 10 electron volts. So this is the total amount of energy that passes through this sheet of glass in 4 seconds. So this would basically be E total. Does that make sense? Yeah? Cool. You're looking for number of photons, so now you need to calculate the energy of a single photon. So to do that, you're going to look at this equation, and basically you're going to need Planck's constant times frequency, and since you don't know frequency, you're going to just substitute that out for Planck's constant times the speed of light over wavelength. Everyone know how we got from here to here? Yeah? Okay.
That's for energy of photons.
Yeah, that's for the energy of a single photon. So, for that second part, photon, Planck's constant 6.626 times 10 to the negative 34, multiplied by 3.0 times 10 to the 8, all over wavelength. That's in nanometers. Did you convert this to nanometers?
Do we not just use the HC that was given?
Oh yeah, actually, yeah, just use the
They
HC
use the
that's
1240.
Yeah, it's probably easier. 1240 over 475. And that gives you 2.61 electrons. So that's E photon. So you have those two parts of the equation. You just need to find number of photons. You would just do photons equals
Talk a little louder.
E total, which is 9.14 times 10 to the 20th over 2.61. And you get the answer of 3.5 times 10 to the 20th number of photons. So that's how many photons passes through, that's how many photons at the wavelength 475 nanometers that passes through this sheet of glass in 4 seconds if the intensity is 975 watts per meter squared. Does that make sense?
Mm-hmm.
Everyone get it?
Do we ever use that 9? Yeah, we do.
What 9?
The 975. I just wanted to know.
Yeah.
We used it at the beginning.
Okay. So the second problem is find the energy released by a hydrogen electron falling from the N3 orbital to the N2. So this is the equation to find the energy at each level, and this is the equation to find the difference in energy between the two levels. Pretty straightforward. So you just plug in. Okay, so from N3 to N2, N3 would be negative 13.6 over 3 squared. So that's basically initial and then final. And you get the energy of the photon, which is 7.889 electron volts. Does that make sense to everyone?
Mm-hmm.
Okay. I think in class he asked you guys to find the wavelength of the photon, but I'm not sure if he got to that point. Did he ask you?
Yeah, I said calculate the wavelength.
Okay, so basically now you have the energy of the photon. So to go back to the wavelength, you use this equation again. So now you have the energy, which is 1.889. And that HC is 1240. 1240. Divided by wavelength. So the wavelength turns out to be 656 nanometers. Does that make sense?
Mm-hmm.
Cool. That's it?
Is the 1240 the E total?
No, the 1240 is the HC, which you can get by multiplying Planck's constant by the speed of light.
Are we gonna do for each one? Just for them, because
I don't know.
might as well do both.
Guys, did that make sense to everyone?
Yeah.
Cool.
We can split up
I
the
guess
room.
make your own problem now.
We can split up the room by who makes what problem.
Yeah, we could.
How about this row and this row make the first problem example, and then the last 2 rows on the side make an example for that one.
Okay, so in the grand scheme of the equation, like, are you using find the lane? Are you using like the
Let's just change the numbers, but instead of doing blue, let's
That